Hi students, this is Viswanath, Chemistry faculty for NEET and IIT exams. In last class, we completed numericals related to enthalpy of combustion. See the next one. Human body requires 2370 kilocalorie of energy daily. If the heat of combustion of glucose is 790 kilocalorie per mole, the amount of glucose required for daily consumption is. So, for one day, human body requires 2370 kilocalorie. Now, heat of combustion of glucose is given for a particular person for daily consumption. How much amount of glucose is required? Okay, glucose combustion reaction. See here, C6H12O6 plus 6CO2 gives rise to C6H12O6 plus 6O2 gives rise to 6CO2 plus 6H2O. Delta H equal to minus 790 kilocalorie per mole. Here, 1 mole of glucose means 180 grams of glucose on combustion produces 790 kilocalorie per mole. For 2370 kilocalories of energy is released. Means then how much glucose is required? For that, do cross multiplication, then we can get this one. That means 540 grams of glucose produce this much amount of energy. So this much amount of glucose is consumed daily to produce this much amount of energy. So option B is the answer. Next, enthalpy of combustion of carbon to carbon dioxide is 393.5 kilojoule mole inverse. Calculate the heat released upon formation of 35.2 grams of CO2 from carbon and dioxygen gas. So, formation of CO2. See the equation. C plus O2 gives rise to CO2. Delta H equal to minus 393.5 kilojoule per mole. In this reaction, 44 grams of carbon dioxide is formed. Then heat released in the formation of 44 grams of carbon dioxide is this one. In the given question, to form 35.2 grams of CO2, how much amount of heat is released? So 44 grams of CO2 heat energy released is 393.5. For 35.2 grams of CO2, how much heat energy? So do the calculation, then we can get this one. So to release 35.2 grams of CO2, to form 35.2 grams of CO2, the released heat energy is 314.8 kilojoule. Okay, see the next one. Standard enthalpy of combustion delta C H naught. The enthalpy change per mole of substance when it undergoes combustion and all the reactants and products being in their standard states at the specified temperature. So already we know that standard state, reactants and products all are present in their standard state, and 1 mole of a substance undergoes combustion. The enthalpy change related in this reaction is standard enthalpy of combustion, represented by delta C H naught. Next, important one, enthalpy of formation delta F H. How can we define the amount of heat evolved or absorbed when 1 mole of compound is formed from its constituent elements is called enthalpy of formation. 1 mole of compound is formed from its elements. Example, formation of carbon dioxide. What are the elements in this? Carbon and oxygen. So this carbon dioxide is formed from carbon and oxygen elements. The heat energy released or absorbed in this process is enthalpy of formation. Standard enthalpy of formation, the amount of heat energy released or absorbed when 1 mole of compound is formed in its standard physical state by the combination of elements taken in their standard states is known as standard enthalpy of formation. Standard enthalpy of formation is represented by delta F H naught. Reactants and products all are present in their standard state and 1 mole of compound is formed from those elements. In that case, the enthalpy of the reaction is called standard enthalpy of formation. This delta F H naught of a compound may be positive or negative. In the formation of some compounds, heat energy is released. In the case of some other compounds, heat energy is absorbed. So it may be positive or negative. Standard enthalpy of formation is negative, then the compound is exothermic compound. Delta F H naught is positive, that is endothermic compound. The enthalpy of a compound is equal to its standard enthalpy of formation. So when 1 mole of compound is formed, that is called enthalpy of compound. That compound present in their standard state and formed from its elements which are in their standard state, then that is called standard enthalpy of formation. That means enthalpy of a compound is equal to standard enthalpy of formation. Next, exothermic compounds are thermodynamically more stable than endothermic compounds because exothermic compounds means by release of heat energy, compound formation takes place, so it has more stability than endothermic compounds. By convention, standard enthalpy for formation of an element in its standard state is 0. It is very important point, students. Remember carefully. So, for an element in its standard state, standard enthalpy for formation is 0. We have to understand that a standard molar enthalpy of formation, delta F H naught, is just a special case of delta or H naught. What is delta or H naught? Standard enthalpy of the reaction. So, in standard enthalpy of the reaction, 1 mole of the compound is formed from its constituent elements in the standard state, that is standard molar enthalpy of formation. If a compound is formed from other compounds, not from its constituent elements, then that is not enthalpy of formation of that compound. Understand carefully. A compound is formed. See the example, CaCO3 is formed. How it is formed? From CaO and CO2. These two are not constituent elements of this compound, then this enthalpy change is not standard enthalpy of formation. That is, I am telling. So a compound is 1 mole of compound is formed from its constituent elements, then only a related enthalpy is called standard enthalpy of formation. Next, if in a reaction 2 moles of the product is formed from its constituent elements, then that enthalpy change is not standard enthalpy of formation of that compound. Example, H2 plus Br2 gives rise to 2HBr. Okay, H2 plus Br2 gives rise to 2HBr. Delta R H naught equal to minus 72.8 kilojoule per mole. Here, how many moles of HBr is formed? 2 moles. From where it is formed? From the elements hydrogen and Br2. From the constituent elements, 2 moles of HBr is formed. That's why this is not standard enthalpy of formation. We need enthalpy change for formation of 1 mole of the product. So, standard enthalpy of formation of HBr equal to half of standard enthalpy of the reaction, minus 72.8 divided by 2, that equal to minus 36.4 kilojoule per mole. This is standard enthalpy for formation of HBr. We can calculate the enthalpy change for the reaction by using standard enthalpy of formation. So standard enthalpy of the reaction is equal to sigma I AI into standard enthalpy of the products minus sigma I BI into standard enthalpy of the reactants. Here AI is the coefficients of the products, BI is the stoichiometric coefficients of the reactants. Okay students, we will meet in the next class.